Section 3, Unit 9, Math 2 is factoring polynomials. This is the beginning of doing the opposite of multiplication. Factoring is the act of turning an addition and subtraction expression into a multiplication problem by using parentheses. That's really what factoring is. There are a variety of different techniques that you can use to factor. You're going to learn several of them. But first and foremost, you just have to know factoring is turning things into multiplication. Things that are being added and subtracted, if you can put it in parentheses and make something multiply it, you've now factored it. That's what our goal will be. Now, we're going to be working backwards and using this area model. That's the first thing that we're going to do. So, let's do this. Let's make sure that you have had time to write down all this information. Let's go ahead and press the Enter button now for students to be able to write down the notes. Press Enter now. Coming back to you. So now that students have this written down, hopefully we know what factoring is and that we're going to be working backwards. But our primary two techniques that we're learning in this section is called Gcf factoring. There is Gcf factoring, and then there's the Gcf factoring of factoring quantities. We're going to be using the same technique. Gcf stands for the greatest common factor of factoring. Greatest common factor. Since that's not written, I'm going to write it down right here. Greatest common factor. And we're basically pulling out the greatest common factor. Now, that can be a number and or a variable or both. It's the opposite of the distributive property. We're going to factor out the largest coefficient that goes into all terms and the highest common degree, meaning it's in every single term that are in each term. When we factor quantities, if there's an addition or subtraction sign in between groups of parentheses, that's a quantity, groups of parentheses. We're looking for a common group of parentheses as the GCF, and we're going to use brackets for that as well. So, didn't write down a lot for this, but I want you to see how it's done and how it's used. I think you'll understand a whole lot more as we do examples. So I have 1, 2, 3, 4, 5, 6, 7, 8 different examples. You might as well get that worksheet going. Let's make sure everybody has a worksheet, worksheet 3 in front of you. If your worksheet 3 is missing something, make sure you put it in there and let's go from there. This is number 1. The area model. Find the missing side lengths. If this times this equals this area, then you should know what goes there. This times what gives you 3x squared? Well, it's got to be a 1. 3 times 1 is 3. And you need another x. 3x times what gives you 15x? 3x times what gives you 15x? And it's a 5. So if I know that this times this is that, and this times this is that, then what we're saying is that this thing multiplies to this thing, the x plus 5, using parentheses for that group. 3x times the quantity of x plus 5 is going to equal 3x squared plus 15x. What you're essentially doing is you are factoring or breaking apart 3x squared plus 15x into 3x times the quantity of x plus 5. This times this is that. You've turned addition and subtract, or addition, into multiplication by using parentheses. That's how it works. That's factoring. So then what they do is they get you away from the area model. They say, well, what's the GCF, and figure out what goes there. So essentially, you're looking at this as a term and this is a term. And you're looking to see what fits, what can go, what's the biggest number that goes into 12 and into 28. Well, 2 goes into 12. 2 goes into 28. Good. Was there a bigger number? Does 3 work? 3 goes into 12. Does 3? 3 doesn't work. But does 4? 4 goes into 12. And 4 goes into 28 7 times? 5 doesn't. 6 does here, but not there. 7 works there, but not there. I think that the biggest number is 4. 4 is your GCF. If you said j to the third, this has a j to the third, but there's no j's here. They do not have a j in common. It has to be a common variable in both terms. There is not a j in both of these things. There's not that at all. So our GCF is a 4 in this case. 4 times what is that? It's like factoring that out. 4 times what is that? It's 4 times 3j to the third. This times that is that. Plus 4 times what is 28? And it is 4 times 7. You leave the GCF in front of the parentheses. This times that should be this. This times that should be that. And it should still multiply to equal the original thing. You can always check to see if you've done it right by multiplying every single time. So keep that in mind. Number 6. So we're still doing GCF factoring. This has a k to the third. This has a k to the second. This doesn't have any k. So what variables do they have in common? This doesn't have any k's. You cannot factor out a k. So when you look at 12 and 9, negative 9 and 6, you go, what goes into all 3 of those coefficients? I hope you know that your GCF is a 3. Your GCF goes in front of parentheses. What does it multiply to get to the original? Goes in there term by term. This times that is that. Minus. 3 times 3 is 9. K squared. 3 times what is positive 6? 3 times plus 2. This times this is that. This times this is that. This times this is that. No other GCFs. That's as far as we can go. So GCF factoring is just like that. The only way it gets harder is sometimes they throw in some variables and they have multiple variables. So let's look at number 12. Is there a number that goes? This is a term and this is a term. So we're looking for the highest number that goes into all 3. And then, is there a common variable? Let's look. This has a c to the first. Let me write a little 1 right there. This has a c to the second. What do they have in common? They both have a c. How many do they have in common? This has at least 1. This has 2. In common, they both have at least 1 of them. That's how I do it. I look at the d's. They both have d's. This has 3, this has 2. In common, they both have at least this in common. They both share at least d squared. Your GCF is 13cd squared. Super interesting GCF. It's what happens when they use bigger variables. And let's just go from there. 13 times 1. 13 times a c is the same as 1. All it needs, there's 3 d's. There's only 1 here. I'm just going to put a d there. 13cd squared times 1d would be 13cd to the third plus. 13 times 3 is 39. I need another c, and I already have my d squared here when it goes there. So there's my answer factored with the GCF. So GCF factoring is just pulling out what do they have in common, what's the biggest number that goes into both. But what they're going to do then to try to confuse you is they're going to try to confuse you when they throw in these parentheses. These 2 examples, 15 and 19, are the examples for the directions that we have under factoring quantities. In quantities, what we wrote down was this. If there's an addition or subtraction sign between groups of parentheses that have a common group of parentheses, the common group can be pulled out as a GCF in front of brackets. Meaning this, remember how earlier we said that x plus 5 squared was x plus 5 times x plus 5? Let me just write that down real quick. Like that's what the little 2 means. Well, this is multiplying an x plus 5 and x plus 5. This is an x plus 5 times an x minus 3. So I want you to look at this like this is a term, 2 things multiplying, and this is a term, 2 things multiplying, and we have a minus sign in between. If these 2 things have a common parentheses, I'm going to circle what I'm talking about, this and this. Aren't these both x plus 5s? Could I use the x plus 5 as a GCF? Absolutely. The x plus 5 would pop out, put it in parentheses, and then we would use brackets. If this popped out and this popped out, what would be left behind would be this guy, and this guy. X plus 5 minus x minus 3. Now I know that might look like it's a crazy answer. It kind of is. Let me erase all this. But let's look at it one more time. You have 2 factors of x plus 5, and x plus 5 times an x plus 5. You have an x plus 5 multiplying this. We're going to just take this and one of the x plus 5s out. And what would be left behind? One of these x plus 5s minus the x minus 3. This times that is that. This times that is that. It's the same thing as what we did before. Now, most of your math teachers are going to like this as your answer. But I need to show you something because I did see something like this on, let's just say, some kind of test that I've seen before. Sometimes you might actually have to simplify what goes inside these brackets. Sometimes you might actually have to do x plus 5 minus the x minus the negative 3. Minus the negative means adding the 3. So sometimes you might actually have to put these together and go, oh, those cancel. And this is the same thing as 8 times x plus 5. I've seen that. Right now, because the directions say factor out the GCF, we did that, you can stop. But I want to let you know, for you advanced students in the class, you might have to keep going if you're on, let's say, an SAT, ACT, or SBAC type of test. Okay? So let's look at this. I have 3 of these. I have 1 of those there. Could we treat that as the GCF? If so, what goes inside? If you pull 1 of these factors out, how many are left? I'm hoping you would see that it's squared, because this times this would make 3 minus. If you pull that out, what would be left? X minus 2. That's how you do number 19. So then that's the majority of your worksheet. Then what they do is they're going to throw in a couple other things at the end of this worksheet to make sure that you remember how to do things from worksheet 1 and worksheet 2. They say these are squares. Write an expression for the area of each shaded region. So we only want this gray area, and we know the outside distance. We know the outside of these 2 distances. So if you think about it, length times width gives you x plus 2 times x plus 2. That gives us the area of this big box, including everything in between. And what we could do is we could subtract the length times width, or the base times height, of x minus 1 times x minus 1. And so you have to multiply before you subtract. This is where I would FOIL if I were you. X squared plus 2x plus 2x plus 4 is x squared plus 4x plus 4. That's what these 2 multiply equal. I'm going to do this, and I'm going to put this minus sign. I'm going to put a bracket so I don't get lost. X squared minus x, negative times the negative is a positive, so I still haven't done this one yet. Oops. Minus x squared minus 2x plus 1. Now I have to subtract all that. I need to subtract the x squared. I need to do the opposite of a negative 2x. I need to add 2x, and then I need to do a minus 1. This is what makes it hard, is that you have to multiply the whole thing, and then you're subtracting the group. So keep in mind that's the number one mistake. X squared minus x squared goes away. 4x and 2x makes 6x. 4 minus 1 is plus 3. There's your answer for 22. Keep in mind, subtracting parentheses, keep it in brackets, and then do the opposite of each of those. That's how you're going to do it. 26 is the last one, and what they're going to try to get you to do is try to do the opposite of the area model, and that is really what's going to lead you into worksheet 4. So if you know that there's a 7x and a negative 7x, and there's a things here, we got to fill in what's going to be what. So I bet you this times this should equal that, right? Like these two times each other should equal that. So I hope you know what goes here, just based off of this is the product. This times what gives you 7x is 7. 7 times x gives you 7x. Now 7, positive 7, let's put the little plus sign there. Sometimes it makes it easier. And this minus sign, I'm going to move that minus sign right there. Times each other is negative 49. Make sure I put that there. And this times that should equal that. So what does that need to be? It needs to be an x, because x times negative 7 would be negative 7x, and that makes this x squared. So what does that mean we have? We have this x plus 7 times x minus 7 will equal x squared minus 7x plus 7x. What does this diagonal make sometimes? 0. X squared, do I write 0? No, you don't. You can just put the first and the last, because the O and the I cancel out this time. This times this is equal to x squared minus 49 is your final answer for 26. That's as hard as it gets. The other ones should be easier. We're going to stop your notes right there.